Hello learners, welcome back to Constant Learners. Today we will discuss the union operation in the context of relational algebra operators. We have already covered the select and project operations. I've shared the link in the description. And now let's dive into understanding union. Union is a very commonly used word in the English language, which means combining or bringing together. This is similar to the union in the set theory that we've studied in mathematics. Let's say we have two sets, A is equal to ABC and B is equal to DCE. Now, if we take the union of these two sets, we get X is equal to A union B, which is equal to, now A has A, B, C. So we'll take that A, B, C, and B has D, C, and E. So we write D. Now C here is repetitive, so we're going to omit that and E. So union has all the elements present in each set, eliminating the redundant or duplicate value. Very similar to this concept is the concept of union in relational algebra. In relational algebra, we are dealing with relational databases where data is stored in the form of tables. The union operation can be used to combine data from two tables, that is, entire columns of two different tables, or we can use union to combine selective data from two different tables, that is, selected columns from different tables. So we can say that union is a binary operator because we need multiple tables to use the union operation. We're going to understand both of these criteria in just a bit with some examples. Let's say we have to get the union of two different tables. Now here table 1 has three columns, ID, name and phone number, and table 2 has ID and name, right? Now, is it possible to get table 1 union table 2? What are the criteria to allow the union of two tables? See, first is that both the tables must have equal number of columns. Now here, do both of these tables have equal number of columns? Is that criteria fulfilling here? No. So the union of table 1 and 2 is not possible because table 1 has three columns, 1, 2 and 3, and table 2 has two columns. And thus the union of these two tables, I'm talking about entire tables, is not possible, right? Now, let's say we have these two tables here. Table 1 has two columns, ID and name. Table 2 has columns, name and phone number. Now will the union of these two tables be possible? See, when we take union of two tables, the first column of the first table, now here the first table is table 1. So the first column of first table will combine with the first column of second table. And the second column of first table will combine with the second column of second table, right? Now, the first column here is ID, whose domain is int. That is, it's going to accept only integer values. I've already explained what is a domain of a column, right? So here, it's going to accept only integer values. And the domain of name is char. That is, it's going to accept only characters, right? But here, the name has char as the domain and phone number has integers, right? Now, in the output table, since we're taking table 1 union table 2, the output table will have first column as ID because the first column for table 1 is ID, right? So this will be the first column in the output table and the second column will be name because table 1 has second column as name. Alright, now ID will only accept integers, right? So when this column will get combined with the name column of table 2, the names will not be accepted in this column here, right? Because here the name can only accept characters, but here we need integers. So the union will not be possible. Again, here we need the characters, but the phone number will accept only integers. Now here in the output table, this name column will accept only characters. So how are we going to accommodate the phone numbers? And thus the union of table 1 and table 2 is not possible. Now let's shuffle the tables a bit. Now in this case, table 1 has two columns, EID, that is employee ID, and first name, And table 2 has student ID and last name, right? Now if you're going to take the union of table 1 and table 2. Now see, both the tables have equal columns and they have the same domain. ID will have only integers as the domain. This ID will also have integers as the domain. First name will accept characters and this L name will also accept characters, right? So this EID when combined with SID, the output will have first column as EID, which will be integers, and thus this column as well as this column. Both of them will be accommodated here. Then this F name will combine with the L name. The output will be, column will be F name, it will accept characters. So all of these will be combined with all of these and all the values will be accepted. But we need to remember that the repetitive or redundant data is eliminated. Repetitive data will not be accepted. Like for example, here we have a person named Rahul. And here, let's say here also we have Rahul. So this second Rahul will be eliminated in the output table. It will come only once. Alright, now. So the criteria for allowing the union of two tables is that both the tables must have equal columns. That is, both the tables must have same arity. This I've already explained in a short video. I'll share the link above and probably also in the description box. You can check that video if you don't understand what is same arity. And the columns must have the same domain. That is, integer column can be combined only with the integer column. The char column will only be combined with the char column. The union of two columns with different domains will not be possible due to structural mismatches. Moreover, if it is not feasible to have two tables with the same structure, we can use the union operation to combine different columns from different tables. We're going to understand with the help of 3 different examples. Let's take the first one. List the names of all the managing directors and employees of a company. So what column do we need? We need the names column. So this is the column that we need. Whose names do we need? First, we need the names of all the managing directors and all the employees. Now, this company's database has 3 tables. Table 1 is this one of all the managing directors. Table 2 is employees. Table 3 is clients. Now, who do we need? We need the managing directors and we need the employees' names, right? So, we need this column from this table and this column from this table. All right. Now, what do we need as the output? We need the names column. Now, if you've watched the previous videos that I've posted about the select and project operations, you will know that whenever we need a column, we use the project operation, that is denoted by pi, right? So how are we going to write the query for this requirement? We're going to start with pi, that is project. What are we projecting? The name column. All right. Now, first, whose names do we need? We need the names of the managing directors. So here the name column is capital. So we are also going to write it capital name and the table's name is MD. And we're going to union this with the names of, again, pi, because we need the names, that is name column of all the employees. Alright, so this is how we are going to write the query. Pi name. Pi means we are projecting the names of all the managing directors who are in the MD table union, and we're going to combine this with the column name of all the employees from the employee table. Next example states that we need to list the IDs of all the students and professors working in the chemistry department. Now the column that we need is the IDs, right, of all the students. So we need to combine the IDs of the students with the IDs of the professors, right? But now here we have a condition that they must be working in the chemistry department. Both the students and professors whose IDs we need, they must be working in the chemistry department, right? So until now, to project a column, we were using the project operation, that is pi. But now we have a condition to select those columns, right? So to satisfy this condition, we need to use the select operation, that is sigma first, right? So where are we going to find the IDs of the students? In this students table. These are the tables and these are the columns or attributes of those tables. So the students table has this student ID and it also has the column department, that is which department they are from. And this professor's table has the professor ID and the department. So we have to use these two tables, students and professors, and these two conditions we need to satisfy, right? So we start with first selecting the students from the chemistry department. So sigma department, the column name is department, which has to be equal to chemistry. Right? So department has to be chemistry. From which table? Students table. Alright? And we also need the department chemistry for all the professors, right? So for professors also, we need the department to be chemistry. Now, what do we need to project? Which column? The IDs column, right? So for this, we are going to use the project operation, that is pi. Now, for students, the ID is SID. Alright, so we are going to project the ID column for students whose department is chemistry, right? And we are going to union this with, again, we're going to project, now the professor's ID is PID. We need to project the professor's ID for all the professors whose department is chemistry. Alright, so first we select all the students whose department is chemistry and we select all the professors whose department is chemistry, and then we project the IDs for both of these students as well as the professors, and then we take the union, that is we combine them both. For the output, the column name is going to be SID because the first column here is the SID column. Alright, and the redundant data will be eliminated. Now next example says that, now here we had two different tables and we needed to combine the data from two different tables. Now here we need to list the IDs. Again, we need the column IDs of all the temporary male employees along with all the female interns. Alright, so again, we need to understand that there are two criteria here. First is they must be temporary but male employees, and here we need all the female and second interns. Now all of this data is stored in a single employees table. So how are we going to do that? So again, we will start with selecting. Who are we going to select? Employment type. So first we need temporary. So employment type is temporary. Male. So both of these conditions have to be satisfied. It is mandatory. So we use AND operation and gender. We have gender here. Gender is equal to M, that is male. Right? Now the table name from the table employees. Again, we have to select employment type is equal to intern, and the interns have to be female. It is mandatory. So again, AND operation, gender is equal to F, and the column will be employees. Alright, now what are we going to project? We are going to project the employee underscore ID. This is the first one. Again, we will project employee underscore ID of the female interns, and we're going to take the union of both of these. That is, this entire thing, union, this entire thing. Alright, so what are we doing? First, we're selecting the temporary male employees from the employee table, and we're projecting their employee IDs. And then you're combining this with the selection of female interns from the employees table. Again, we are projecting their employee ID. So the output table will have the column employee underscore ID. I hope that this was clear. The last example says that list the names. That is, the column that we need is the names of all the students and professors. So here the tables that we have is department, students and professors. So we need the names of students and the names of professors in the physics department who joined in the year 2022. So again, there are two conditions. First, they must be from the physics department. So that we will get from the department who joined in the year 2022. So for the students, we can get that from the enrollment date. And for the professors, we can get that from department and hire date. So these two conditions must be satisfied, that the year must be 2022. So if you're saying that they have joined in the year 2022, so we can say that the date has to be greater than or equal to 1/1/2022, right? And in the physics department. So it's very easy. You have to take both first name and last name. You have to project two columns here. Again, here you have to project these two columns. All right. I'd like you to solve this by yourself and share the answers in the comments section. I will also make sure to share the answer as the pinned comment. Kindly see that only if you are unable to solve this by yourself. Solve it. Share the answers. If you like this video, if you understood the union operation, don't forget to give this video a thumbs up. Subscribe to the channel. Share it with your friends. And thank you so much for watching.